We essentially got 20 guys, gave them a breakfast, which was standardized. Then we gave them the Amarasate pill, targeted to the small intestine, an hour before an eat till you're full lunch. And then 2 hours after that lunch, they had an eat till they were full snack. And what we did was we measured how much food they were eating at the meals. We measured what their hormone levels were, so we took 16 blood samples throughout the day. And so they ended up eating less food at the lunch, although not significantly less, but significantly less food at the snack, and combined about 18% less food at the two meals. So when taking Amarasate versus a placebo, they had 18% less energy voluntarily from the meals. They also had a change of GLP-1 and CCK levels, so 3 times from baseline from the placebo, and we got 6 times from baseline with the Calocurb. So that's, a really huge difference.
In a world, just because I like to sound like a movie announcer, I'll just say an era of increasingly popular weight loss drugs. You guys know about them. GLP-1 agonists, Ozempic or semaglutide, Victoza, liraglutide, Wegovy, Saxenda. They all sound like aliens. I know a lot of you have been looking for ways to satiate your monstrous cravings without necessarily taking the peptides. And I've been really on a quest to look into all of the alternatives, right? I've talked about liquid ketone esters. I've talked about Akkermansia. I was just reading my buddy Joel Green's new book, which I'll interview him about soon, where he talks about mixing honey and stevia and the interaction of those to activate the hunger hormone ghrelin. But one of the more powerful things I have been trying lately, particularly in the afternoons, makes me not think about any food until dinner, which is kind of a miracle for a foodie like me, is this plant-based extract I wanted to talk about on today's show, because it has some really interesting research as far as clinical data on reducing hunger, cravings, calorie intake by pretty impressive percentages, like double-digit percentages, acting in a very similar way as these GLP-1 agonists to stimulate hunger hormones or satiety hormones like cholecystokinin or CCK, GLP-1, PYY. I decided to get a guy who knows way more about this particular plant extract than I do on the show to talk about this. His name is Dr. Edward Walker. Dr. Edward Walker is joining me from Salt Lake City, but he's actually based down at University of Auckland in New Zealand, where he works at the New Zealand Institute for Plant and Food Research, where he digs into all these crazy chemicals that we can get from plants. And gosh darn it, he's got a doozy on his hands now because he found the one that could quell hunger pretty dramatically. So, Ed, welcome to the show, man.
Well, thank you for having me.
Yeah. So I'm just curious about how you got into studying up plant matter in the first place, before we get into hunger and satiety. I'd love to hear just about your research in general.
Yeah, so I started off with my Ph.D., which was on the antioxidant effects of berry fruit. So essentially, when you eat what people have done in the past is when they've been looking at antioxidant effects from plants, they'll get, say, the blue coloring from blueberries, and they'll put it into a plate in the lab which has, say, brain cells on, and they'll say, oh, wow, it's got this amazing antioxidant effect. It can stop all this damage from hydrogen peroxide-based oxidation, etc. But the problem with that is that blue compound, or those blue colors from blueberries, they don't actually make it into your blood and they don't make it into your brain. So if you eat blueberries and you cut yourself, you don't suddenly bleed blue. When you eat a blueberry, what happens is that blue compound is very unstable and it breaks in half and forms what's called a dihydroxybenzoic acid. So it's an anthocyanin, which is colored, to a dihydroxybenzoic acid, which is not colored. And that's what floats around your body and that's what gets into your brain. So my research was testing the effects of the dihydroxybenzoic acid that's in your body rather than testing what's actually in the plant originally. Yeah. And we could show, it was interesting because there were still some antioxidant effects present, but they weren't as strong. And there were also some pro-oxidant effects that would occur. So these molecules would have a sort of a change over time when they'd go pro-oxidant and antioxidant depending on the conditions they were in. So you're getting sort of this interesting, dichotomy of response.
How do you differentiate between the reaction of the cells in vitro in the dish that you described versus in vivo in the body? Like when you're delivering the blueberry extract in the body, are you measuring certain metabolites that it's producing in the urine or the blood or something like that?
Yeah. So what you can do is you can essentially measure the blood to make sure you're getting the diet. Well, so you feed the blueberry compound, you measure what's in the blood, and then you can take a series of samples. You can take blood samples and measure antioxidant capacity. Or in my case, we were doing animal trials for that, and we were taking whole tissues. So we were looking at intestine, testicles, brain, liver, kidney, etc.
Did you test just blueberries or did you test other antioxidants too?
Well, so I tested a series of dihydroxybenzoic acids, which are metabolites from various different anthocyanins from different plants. So they cover things like strawberries, blueberries, black currants, cranberries. Yeah, they all end up as a similar sort of molecule in the blood.
What do you think, based on what you've seen in your research? I realize this is kind of a loaded question. Is the best berry for people to be consuming as far if we were looking at the antioxidant particularly?
Yeah, yeah. So I'm personally quite a big fan of black currants, which of course are a berry
Oh
fruit,
yeah.
and they've got a lot of really interesting biological effects. They're not the best tasting, but there's almost a correlation between how unpalatable the berry is and how good it is for you.
Is there something to be said? I interviewed a long time ago this gal named Joe. I'm going to blank on her. Joe Robinson, the author of Eating on the Wild Side. She makes a case that plants that are wild harvested and exposed to more stress in nature tend to have a greater amount of antioxidants and also pass on a higher amount of that so-called xenohormetic effect to the individuals who consume them. Is there something to be said for domestically grown versus wild berries, you think?
Yeah, so absolutely. If you're looking at something that's wild grown, it will have higher levels of most of those protective antioxidant compounds. And even in New Zealand, we have, for example, high levels of UV light. And that high level of UV light will stimulate more of the colored compounds to be made in berry fruit, in black currants, etc. So yeah, so I think that's absolutely correct.
Have you heard of Oregon grape, by the way?
No, I haven't. No.
Okay, I'm just curious because it grows like a weed in my backyard, and I had a plant forager expert come over and walk me through all the plants in my yard. He showed me I could shave the root of it, and it has some kind of berberine-like qualities and also some antiviral and antibacterial properties. But the berry, kind of similar to black currant, is very small, very bitter, very tannic. I suspect it would probably have a host of antioxidant effects. I harvest them and will sometimes drop them into my smoothie. And like the black currant, they don't taste amazing, but I would imagine the antioxidant content is pretty high.
Yeah, you're probably pretty safe in that. They're probably packed full of antioxidants.
Yeah. The interesting thing about the antioxidants is many people, and I want to get your take on this, will say that the timing in terms of your dosing, particularly relevant to exercise, is important because if you take in some of these powerful antioxidant compounds, even many of these, berry powders, greens powders, things like that people are consuming as supplements, you could blunt the endogenous antioxidant production or even the inflammatory response to exercise that could be beneficial for things like mitochondrial biogenesis or satellite cell proliferation or some of these things that people would want as a hormetic response to exercise. Did you come across any of that in your research or have you thought about that at all?
Yeah, so I mean, what typically happens is if you're taking an exceedingly potent antioxidant, in particular one that's only a chemical antioxidant, so like something like vitamin C or vitamin E, and you take a mega dose immediately before exercise, there's a pretty good chance you'll blunt any adaptation you get to that exercise. So, for example, if you take a gram of vitamin C before you go for a run, you may be able to run further, but if you measure your mitochondrial adaptation proteins, you'll find that they're decreased. So your body is not adapting to the exercise. So they're sort of I guess it's horses for courses. So if you're doing a one-off like race or something, fine, you can load up on antioxidants. But if you're trying to get fitter over the long term, you probably don't want to be having mega doses right before exercise. If you're talking about these things like berry fruit extracts, etc., well, they're a little bit of a different kettle of fish because in the body they're not as strong of a chemical antioxidant as, say, vitamin C and vitamin E are. And they also have the ability to sort of stimulate some oxidative stress as well as protect from oxidative stress. So they're less of a concern when you're looking at exercising and timing.
Yeah, you just made a really good point, because what people don't talk about when they discuss this idea of antioxidants post-exercise is the sourcing. And it sounds to me like, based on what you just said, if we're looking at a lot of the bitter tannic compounds and some of the xenohormetic agents in a berry powder or a handful of blueberries, or sea buckthorn or blackcurrant or something like that, you might be just piling a little bit of extra xenohormesis on top of the hormetic stress of exercise itself. And if you're not doing a high dose of, say, like a synthetic extract, like a straight up synthetic vitamin C or vitamin E supplement, you could arguably be doing yourself a favor by saying, putting a handful of wild blueberries in your post-workout smoothie or something like that.
Yeah, and there's certainly some data to support that with black currants as well, looking at the a favorable change in post-workout inflammation and antioxidant profile going towards adaptation.
Yeah, so for everybody who enjoys a glass of wine, rich, red, antioxidant packed wine post-workout, maybe you can get away with it. But I do think it is a good point here. I think a lot of people are almost like orthorexically avoiding antioxidants post-exercise, when I think you made a good point that it comes to the concentration of the antioxidants and also the delivery mechanism, right? Whole food or powder-based versus some like high-dose vitamin C or vitamin E supplement.
Yeah, absolutely.
Yeah. So when it comes to the idea of this other molecule that I've actually been super interested in, that I know you've done some research on, Amarasate, I think it's called?
Amarasate.
Amarasate. Tell me about Amarasate and when you first discovered that and where that fits into the picture of the particular thrust of this podcast, hunger management.
Yeah. So, I mean, this work all started in 2009 when we got a grant from the New Zealand government that kicked off in 2010, looking at plant compounds that could be used to essentially suppress appetite for weight loss applications. And so the concept was that plants have been using compounds to regulate appetite for, basically forever. So if you think of an apple tree, the apple tree sits there, it grows an apple, and what it wants you to do is to come and eat the apple and then not eat anything else around it. So you don't eat the leaves and you don't eat the apple seeds. So what the apple tree actually does is it creates a series of compounds in the leaves that are anti-fedative. So they actually have a mild appetite suppressing effect, so that if an animal comes along, it'll eat the apple because the apple tastes good, and it'll leave everything else around so it tastes bad. And if it does eat it, its appetite's reduced, so it eats less of it. And so we used that sort of concept as a basis for this research, and we really said, well, what's the best plant-based appetite suppressant we can develop? We then looked at, I guess, what's been used historically. So if you search through various cultures, there's a history of using highly bitter food to suppress appetite. So that's done in the Highlands of Scotland. They would use a bitter heath pea to suppress appetite during times of famine. In the Kalahari, the Bushmen of the San will use a bitter cactus to suppress appetite during times of when they're hunting and they're going in the desert and they can't get any food. And bitterness has been used in both Chinese and Vedic medicine for regulation of appetite as well. And so we looked at that. We thought, okay, there's looks like bitterness is potentially involved a bit, but there was a little bit of a snag, and the snag was the Romans, because the Romans used bitterness to increase appetite. So they'd have a bitter-infused wine before they'd have a meal. So you end up with this sort of a little bit of a confusing situation.
Wait, how do you know that was to increase appetite? That was the reason that they did that?
Well, it was part of their, their what they call standard operating procedure before a feast. They drink the wine in order to get the gastric juices flowing, and so they could eat more food at the feast.
Yeah, it's like a kind of like an incretin agent to increase the hormones or the digestive enzymes responsible for activating some of the ability to be able to process the food. To me, this sounds a little bit similar to how in Okinawa they'll use bitter melon prior to a meal.
Yeah, exactly. And so that was sort of interesting because there were these two different ways of bitterness would regulate appetite. And so one of the ideas was we had to figure out what that was. And we were actually really lucky because right at the start of the project in 2011, a paper was published in PNAS where they got a mixture of a whole bunch of pretty nasty bitter synthetic compounds, and they gavaged, so they basically squirted directly down the throat into the stomach, this mixture into mice. And what they could show was that very quickly after they did that, the mice would eat more food. And then after an hour or so, the mice would eat a lot less food. So there was this temporal change. And that temporal change lined up with when the food was in the stomach, when the bitterness was in the stomach, they were eating more. And when it passed through into the small intestine, the mice were eating less. So we came up with an idea that we called the bitter break, which was that if you deliver potent bitterness past the stomach into the small intestine, you will stimulate the small intestine to release a whole bunch of anti-appetite hormones. In this case, it would be CCK, GLP-1, which is really topical at the moment, and PYY, and that would be the reason why appetite would be suppressed. So we basically started with that, and then we went through and did a whole bunch of clinical, preclinical, and clinical research to validate that and to discover a singular plant extract called Amarasate that was highly effective at doing this.
Well, before we get into how you actually package up Amarasate to get it to pass through the stomach and then to instead hit the bitter receptors in the small intestine, based on what you just told me, could it make sense if I did want to decrease hunger or decrease the amount of food I'd eat in a meal by pre-dosing with something bitter to actually say, like, I don't know how long it would take to pass through the stomach and hit the small intestine, but to consume my bitter compound of choice, let's say the handful of Oregon grapefruit or the Oregon grape berries from my backyard, say like an hour before a meal, could you make a case for just timing your bitter compound, bitter wine, bitter berries, maybe the peel or a citrus extract or something like that, well before a meal, like an hour before?
Yeah, so I mean, there's two things to look at there. The first one is the time frame, an hour before a meal. So yes, you'd need to go an hour and a half before a meal on an empty stomach to get it through to the right place in the gut. The challenge is that in order to trigger those receptors in the gut, it has to be really, really bitter. So when you talk about grapefruit's got naringenin in it, and that's been tested previously to see if naringenin will decrease appetite, and it doesn't do it. So it's simply not bitter enough. And that's one of the things we discovered in the course of the research was that your stomach or your gut is pretty resistant to wanting to suppress your appetite. So humans are wired up to eat, right? And so you need a really strong signal to say stop eating. And so during the research, we screened around 1,000 different plant extracts and chemicals to try find something that would actually trigger the release of those hormones. And we really, or at least in the lab, and we really only came across a handful of compounds, and most of them were not suitable for use. So in theory it works, but in practice you need something that's so bad you really couldn't eat it.
This is interesting, and I'm wondering if my friend who's a nutritionist, Joel Green, is listening in, because I just finished the second book in his Immune Code series, and he really makes a case in that series for consuming, say, like grapefruit prior to a meal, or bitters, or a handful of berries, etc., based on the theory that you've just outlined, that the bitterness would increase the production of satiety-inducing hormones, increase potentially digestive enzyme production, etc. But it sounds to me like what you're saying is that when you flesh it out in research, those compounds just aren't bitter enough. And you're looking at a nearly unpalatable level of bitterness to be able to truly cause the release of a significant amount of GLP-1 agonist-like hunger-suppressing hormones.
Yeah, so that's certainly our experience. I will say one thing. If you're talking about getting the gastric juices flowing in the stomach for digestion, then the bitter threshold is quite a lot lower. So so you can certainly do that, and even caffeine will help do that.
Okay, and is the bitterness threshold also lower if you were just doing this for blood glucose management? Because one of the things that I've talked about in the past, for example, using the Okinawan analogy I was referring to earlier, the use of bitter melon prior to a meal would be that would have a blood glucose lowering effect when you have the meal. Does the bitterness also need to be nearly unpalatable to have an impact on the blood glucose?
Well, so we haven't done research directly on that, but what I can say generally is that it is easier to lower blood glucose than it is to suppress appetite. So you'll need to generate less of an effect to lower the blood glucose than you would to have an effect on the suppression of appetite. And there's also a lot of mechanisms which aren't related to GLP-1, which will lower your blood glucose, such as inhibition of glucose uptake, which a lot of plant compounds will do. So I'd say it's easier to lower blood glucose than it is to suppress appetite.
Yeah, that makes sense, and it agrees with my own anecdotal testing. And by the way, the show notes, if you do want to check out the video and the show notes and the resources to go along with this episode, go to bengreenfieldlife.com/calocurb, CALOCURB, bengreenfieldlife.com/calocurb. But anyways, if I have, say at a restaurant, bitters with soda water and a squeeze of lemon, or if at home I have apple cider vinegar with some squeeze of lime, for example, in it, I do have a lower blood sugar response to that meal. I even had bitter melon extract capsules, the Keon Lean that I'll sometimes have prior to a meal. And all of those seem to lower blood glucose. But it sounds to me like it's, as you've just said, it's easier to do that than to suppress hunger. And all of these strategies that I'm using are going to have a bigger impact on blood sugar than they are on actual hunger.
Yep.
Okay, so back to the Amarasate. What did you do next with the Amarasate once you found out that it was bitter enough, if it went through the stomach and hit the receptors in the small intestine, to suppress hunger? What did you do next to actually somehow make that doable, to actually get it to the point where it could do that?
Yeah, so we did so when we identified it initially, what we did was we took gut cells that have GLP-1 in them and bitter taste receptors, and we screened all of these compounds. We screened about 1,000 compounds. From that, we ended up with a short list of essentially four different plant extracts that really work to stimulate GLP-1 from the cells. We then thought, well, okay, what are we trying to do with it? We're trying to get it through the gut into the small intestine. So we did a series of stability testing. And so we said, all right, which of these is going to be stable enough to actually work in the gut? Because there's no point delivering it to the gut and have it just break down in a couple of minutes. And we found that only the Amarasate extract was stable and also not toxic. So we had one compound which was isolated from potatoes, which was gut stable. But when we looked at what it actually was, it ended up being alpha-solanine, which is a toxic glycoalkaloid in potatoes. The other compounds we found were small peptide molecules that were highly unstable in the gut, and they just disappeared like that when we did a model digestion.
Yeah, and by the way, not to interrupt you too much, but that's the beauty of nature, is that if you're eating a whole potato, especially a cooked and cooled whole potato, from what I understand, the resistant starch and the impact on the microbiome actually helps to protect you against some of the toxic solanine-based compounds in the potato. So it goes back to kind of like some of the complexities and intricacies of nature and eating whole foods. But again, it sounds to me like if you really wanted something super bitter, like the actual solanine extract itself, the toxicity would be unfavorable.
We were over what they call the LD50, which is the lethal dose 50 for humans, in order to trigger those cells. So people would be losing weight, but not for the right reason.
Yeah, that or just eating a shit ton of potatoes to get the same effect, which would be kind of paradoxical.
So anyway, so we got this extract. We knew it was stable. We then did quantification to see what the bioactive compounds were, because if you want to make a product out of something, you need to be able to standardize the bioactives. We identified 6 bioactives, one primary bioactive, which was called cohumulone. We tested them individually to make sure they had activity in these cells, and And basically, so we had our formulation set. We then did another in vitro digestion where we looked at dispersion of it in the gut. So basically, the extract is like a thick wax, and if you put it in a pill and swallow it, which you do, this is a tip. Whenever a scientist is doing work on a natural product, they always take it themselves before they give it to anyone else, even though you're not meant to. So we put it in a pill and we swallowed it, and what we found is that quite often it would pass through your entire system without being digested. So it would pass through as a thick wax. So we formulated it with a small amount of vegetable oil and tested the gut dispersion. And what that allowed it to do is basically get to your small intestine and then disperse enough so that it can contact with the gut membrane or the gut surface to stimulate these hormones and progress through as a high concentration bulbous mass all the way through your gut, thus giving you sort of not just GLP-1, but also CCK and PYY secretion and potentiating the signal for a reasonable amount of time.
Now, I know some of my highly aware listeners may have heard you say vegetable oil, and their spidey sense went up and all the hair on the back of their neck stood up because there's so many people trying to avoid rancid, damaged seed oils these days. If you're packaging or using a delivery mechanism that includes vegetable oil in the Amarasate, do you think that's problematic, or is it a very small amount, or do you know anything about the potential for the excess linoleic acid or anything like that?
Yeah, so the oil is naturally high in vitamin E and quite stable, and it's also primarily monounsaturated, so primarily oleic acid. There's also a small amount of rosemary extract added to the final formulation to prevent the oil from oxidizing. And the Amarasate extract itself is actually quite high in antioxidant capacity. So we've done stability testing, and we certainly don't get rancid oil, and it's unlikely to be breaking down. So it's also a very small amount.
Yeah, you use a similar strategy to what we did with our omegas at Keon. We get anchovies off the Peruvian coast, but then we use rosemary, small amount of vitamin E, and astaxanthin to stabilize the oil in the soft gel capsule. So you guys are kind of doing something pretty similar with this stuff. Where do you actually get, I should have asked you this earlier, just because I think it is interesting, where do you actually get the Amarasate? What plant does it come from?
So it comes from a hop plant, a particular variety of hop grown in Nelson in New Zealand that has a very favorable what they call hop acid profile. So it's very good at stimulating the release of hormones from these cells. It's then for the encapsulation, it's sent to America and encapsulated in a patented capsule that releases just as it leaves the stomach and opens up in the small intestine.
You mean hops, the same stuff that's used to make beer?
The same thing that's used to make beer, yeah.
Could you guys kind of make beer for your company as a byproduct of all the hops that you're using, or does that not make sense?
So, so it's interesting. So it tracks back a little bit to another piece of work we did, which was right at the start. We weren't sure if these bitter taste receptors or bitter taste buds were really in the gut, right? So there was a little bit of debate at the time when we started. So I actually went into hospital and got people to volunteer biopsy samples from along their guts. So we got 30 people to give biopsy samples from 10 regions in the gut, and we measured the bitter taste receptors. Now, there are 30 of them, 25 in humans, of which most people had 17 of them present in their gut. But this is where it gets interesting. When you get hops, the hops compounds, so out of the flower, so without being turned into beer, trigger two receptors, and those two receptors are present in your gut. When you boil the wort of the beer and turn it into the compounds in beer, they trigger one receptor, and it's not in the gut. So beer doesn't have the capacity to trigger the receptors that suppress your appetite in the gut. So we could make beer, but it wouldn't be appetite suppressing.
Well, you could use this to enable someone to drink less beer, potentially. So I'm just curious. I've never tried this. I've got the Calocurb stuff in my pantry, which has this Amarasate formula that you talked about, that you've been talking about in it. I've never broken open the capsule to see how bitter it actually is, but have you?
Yeah, I have. So it's really interesting. So when when you look at the bitterness from beer, right? You think you drink it and it's bitter and then it's gone, right? With Amarasate, it's very different. So it's less water soluble, so that's why it's in a little bit of oil. And if you crack it open onto your tongue, you'll taste like not much for about 30 seconds, and it slowly builds and builds and builds and builds, and it becomes unbearable, and it will not wash off. So you will be tasting really strong bitterness for about 2 hours afterwards.
This really actually makes me wonder, have you ever heard of a miracle berry?
I have heard of miracle berries. I've taken miracle berries before. Yeah.
Yeah, so for people who don't know what these are, it's a berry, and you can buy like a lozenge that has the berry extract. For example, on Amazon, if you go to bengreenfieldlife.com, and I'll put a link in the show notes. I even wrote a whole article about how to throw your own miracle berry party, where you get all sorts of bitter and sour things. Because what it does, this might be bastardizing the actual mechanism of action, but it essentially causes all the bitter and sour receptors to instead taste things as sweet. So like a cherry tomato tastes like the sweetest grape you've ever had, and apple cider vinegar tastes like cherry soda, and plain old yogurt tastes like vanilla ice cream. It's incredible. A lot of people will use this to lose weight because they can eat arguably healthy foods or fermented foods, and they taste much more palatable. I'm just curious if I were to break open the Calocurb capsule, what the Amarasate would taste like with a miracle berry coating.
Yeah, it'll be interesting. It'll either the Amarasate will be so bitter that it won't work, or it will become so unbearably sweet because you'll be having so much sweet signaling.
Well, the more bitter and sour something is, the more sweet it seems to taste. So I would imagine it might just taste overwhelmingly sweet.
It's interesting you mentioned miracle berries, because there's also, for some people, they'll reduce the spiciness sense as well and make that taste sweet.
Yeah, that's another good one. Hot sauce tastes like cherry juice.
Yeah. So if you have the party, you can line up a whole bunch of ghost chilies, and you can eat one and say, "Oh, it's not a spicy chili, guys." And then everyone else won't have the miracle berry, and they'll be on the floor.
Yeah, and the next morning everybody will hate me because it's like razor blades coming out your anus after the party. So, anyways, though, I'm just curious. Kind of the elephant in the room here is obviously Ozempic's pretty powerful stuff. I mean, I've had friends who have taken it who'd get nauseous around their favorite foods. I can't say that when I've used Calocurb, which has this Amarasate in it, that I felt nauseous. I just don't think about food. Like, it absolutely suppresses hunger. But I'm just curious how you think something like Amarasate compares to a popular GLP-1 agonist like Ozempic.
Yeah, so it's a really good question. So I guess there's a few different ways you can compare it. The first way is that when you think about these gastrointestinal hormones that suppress appetite, they all have the same kind of dose response. So at a low level, they do nothing. At a higher level, they suppress appetite, and at a higher level than that, they cause gastrointestinal upsets. So the advantage Amarasate has over something like Ozempic is that Amarasate is triggering 3 different appetite-suppressing hormones. So you've got CCK, GLP-1, and PYY. So you only need to push them up a little bit and not risk going into that side effect profile area. With Ozempic, you've only got GLP-1 activity. So you have to, so it's much more common to push it high enough and get up into that side effect range. The other difference is that Amarasate will be triggering your own release of these hormones. So rather than a synthetic hormone that's been modified, which is what Ozempic is, or the semaglutides, where they've taken GLP-1 and they've changed a couple of the amino acids to modify how it breaks down in the body. So the half-life changes from 2 minutes to 1 week. We're stimulating natural hormones. So if you take Amarasate, what happens is you have it before a meal, and normally your GLP-1 level goes up to there. With Amarasate, it goes up about twice as high. Then it goes back down again. It's a little bit extended, but it goes back down again, lasts a couple more hours than normal, and then you're down to flatline again. Whereas if you take Ozempic, you've got high GLP-1 in the morning, high at lunchtime, high in the evening, high at night when you're normally sleeping. So it's a very unnatural GLP-1 activity, whereas Amarasate is a very natural way of just boosting your natural rhythms, your natural response to a meal. So it's a bit more potent.
Okay, I've been using Amarasate in the form of this supplement called Calocurb. It's a very small capsule. I've been using 2 after lunch, but I was waiting until this podcast to ask for a little bit more specifics about timing and dosing of Amarasate. Are there specific times of day or proximity to meals that work best if you're going to use this?
Yeah. So it's there's a little bit variation between people. So this is the challenge of having a gut targeted extract, which is what Amarasate is that, people are a little bit more different when it comes to their guts than they are if you're targeting the blood. But generally speaking, you want it to get through the top of your small intestine. And to do that, it's usually best to have it on an empty stomach and about an hour or so before a meal. But that's not a hard rule for everyone. So people might find that their gut's empty very quickly and they can have it, sooner after a meal than someone else can. Or you may find that you can have it closer to a meal again because your gut's empty more quickly. So there is a little bit of optimization to go do for people, but for most people, an hour before a meal is your ideal time.
Before every meal, or do you just need for one meal a day?
Yeah, so it really depends which meal you're struggling with. So if you want to extend your satiety from, say, dinner because you snack late at night, then you'd want to take it before dinner. And if you don't have any problems with making healthy food choices at lunch and breakfast, then you don't need to take it before then. But for most people, they'll usually take it before 2 meals of the day. 2 capsules would be the standard dose. And then they can lower their food intake at those meals and extend their satiation afterwards.
Okay, got it. I'll adjust my dosing mechanism because what I've been doing is I have lunch around 1, and then right around 2 or so, I've been taking a couple capsules of Calocurb. It still seems effective because I don't think that much about snacking and dessert after dinner. Usually my biggest temptation when it comes to high calorie intake is going back for seconds and thirds at dinner. And it seems to help the most with that. And also with keeping me, because we have dinner about 7. And before starting to use this, I'd start to think about dinner like around 5:30. And then it was just like an hour and a half of taming the beast and kind of shutting up the inner bitch and waiting until dinner. And now I just don't even think about food until dinner arrives. And I eat a lot less at dinner. So I'm going to try using it maybe like an hour before lunch. And then maybe again, maybe like an hour before dinner and kind of compare. But a couple capsules would be the dose.
Yeah, a couple of capsules and see how it goes. And for most people, that's probably the best approach. But you may find that your gut's very efficient at emptying from the stomach. And if that's what's happening, then there's no problem with you having it after lunch as you've been having it already.
Tell me about any studies you've done on it.
Yeah, so we've done, so outside the preclinical research, we've done 3 clinical trials. So the first clinical trial was the mode of action trial, where we essentially got 20 guys and we cannulated them. So we stuck a needle in their arm, gave them a breakfast, which was standardized. So just a fixed 2 megajoules. So that's how many calories? About 500 calories of a breakfast. Then we gave them the Amarasate pill targeted to the small intestine an hour before an eat till you're full lunch. And then 2 hours after that lunch, they had an eat till they were full snack. And what we did was we measured how much food they were eating at the meals. We measured what their hormone levels were. So we took 16 blood samples throughout the day. So we measured their CCK, their GLP-1, their PYY, and also their insulin and glucose levels. And so they ended up eating less food at the lunch, although not significantly less, but significantly less food at the snack, and combined about 18% less food at the 2 meals. So when taking Amarasate versus a placebo, they had 18% less energy voluntarily from the meals. They also had a change of GLP-1 and CCK levels, so 3 times from baseline from the placebo, and we got 6 times from baseline with the Calocurb. So that's a really huge difference. And I think there's an important point to be made here is that GLP-1 is released to a lot of things. So it's released every time you have a meal. And if you have a decent sized meal and eat till you're full, a 3-fold is pretty normal. But if you want enhanced bioactivity, so you want to feel essentially extra full, then you need to get above 4-fold. So if the treatment's not going above 4-fold for CCK and GLP-1, then you're probably not getting any additional biological effect. So that fact that we got 6-fold is really meaningful and really important.
That's pretty incredible. Do you have any implications of getting Amarasate face? because people are concerned about like muscle loss, wasting, collagen, elastin degradation, et cetera, with Ozempic. I'm just curious if you run the same risk with something like this.
Yeah, so I don't believe so, and the reason for that again is that we're tracking physiological processes. So we're boosting up that natural level and extending it a little bit, but you're not having GLP-1 activation 24 hours a day. Your body gets a chance to reset, and I think that's really beneficial for maintaining your homeostasis.
It's a really good point, a good differentiator, right? We're not talking about long-term elevation of GLP-1. These are short surges that would suppress overeating at a meal, but not necessarily result in such an impact that you're eating, I don't know, like 60 grams of protein a day and 1,000 calories less than you need to be, and experiencing, essentially like drug-induced cachexia.
Yeah, exactly. Yeah. We also managed to show in that study that people had a reduced insulin load to the meal and reduced glucose levels immediately post meal. So these guys were glucose normal, so they're not diabetic. So it was only a short-lived change in glucose response, but immediately post meal, the glucose response was so glucose level in the blood was about half in the Amarasate treated group to the placebo treated group.
That's interesting. I'm just curious. A lot of times you'll see with these bitter compounds some kind of a thermic effect, even like a white adipose to brown adipose tissue conversion. You guys look into anything like that?
Yeah, so it's on the list of things to do. What you find is that CCK, which again we trigger a lot of, has the ability to convert, or in animal models anyway, convert brown adipose tissue, so white adipose tissue into brown adipose tissue. And so if you get a mouse and you basically inject CCK into it or trigger CCK, you'll cause that conversion. And then if you block the CCK with a CCK blocker, you inhibit the conversion. So it's probably pretty likely that anything that's getting a decent CCK secretion would have the ability to convert, non-active fat into active fat and to up your metabolic rate. So it's on the list, and we're pretty hopeful that we'll be doing that, but future science.
Well, besides the gastric consequences of combining it with ghost chili peppers at a miracle berry party, which could, of course, result in disaster pants, any effects colonically? Like, do people need to worry about liquid poo, constipation, diarrhea, anything like that?
So the side effects are reasonably uncommon. In the clinical trials we've done, when we look at the side effect profile, and these clinical trials are probably worst case scenarios because people have never taken it before, so their body's never had a chance to adjust. We see somewhere between a 5 and 10% occurrence of a loose stool that's not associated with nausea. So basically like almost a flushing effect, so like a detox. And so 5 to 10% of people may get that. In the real world feedback, it's less than 5%. And very occasionally, someone will get nausea. And that's usually because the capsule is opened in the stomach rather than in the small intestine. And they've got a whole lot of acid secretion going on. And then that causes them to feel a bit uncomfortable. And usually you can fix that by altering the timing towards versus the pill versus the meal.
Yeah, I've got a little bit of a princess gut myself, and I've done just fine with it. As far as the impact on the microbiome, though, kind of a similar question. Have you guys looked at anything regarding microbiome balance, change in bacterial balance, anything like that with the introduction of such a bitter compound into the gut?
Yeah, so we haven't looked at that currently. What I will say is from animal studies where they've given hops compounds, what they see is that there's none present in the feces when it comes out. So the primary point of metabolism appears to be somewhere in the upper colon. So that's a little bit reassuring that the compound is unlikely to progress through into the lower colon where it would have an effect on gut bacteria.
Okay, good. So leading up to my interest in GLP-1 agonists, I primarily used exogenous ketones to suppress appetite with maybe some sparkling water and chewing gum thrown in. And then I got interested in alternatives to Ozempic with its popularity and a lot of the problematic side effects of it, and came across Amarasate and this supplement Calocurb, experimented pretty successfully with that, and I have a lot of my clients using it now. And then I also came across Pendulum, a company that is producing a Akkermansia combined with a probiotic called L-butyricum and lactobacillus as more of like a microbiome-induced approach to GLP-1 agonism. What do you think of that approach?
Yeah, well, it's quite interesting. I think that we actually considered doing that in the project, but we rated that as a lower target than using the bitter taste receptors. So GLP-1 is present through a lot of the small intestine and the large intestine, so you can trigger GLP-1 release by changing the environment of the large intestine. Akkermansia is interesting, and there's some quite good lab-based data, so in vitro data saying that it can trigger GLP-1 release. And there's also some human clinical trials, at least a human clinical trial, that shows a decrease in blood glucose and HbA1c after 12 weeks of supplementation. But I'd really be looking to see if that's a GLP-1 mediated event, because you can regulate blood glucose a lot of ways, and they haven't. And I'm yet to see a human study where they actually show GLP-1 being released. It's all lab-based at the moment. So I think there's a lot of potential there, but still more science to do.
Yeah. Like I know for ketones, for example, the impact is on ghrelin, but I don't think it's through the GLP-1 pathways. And I know the Amarasate is. It's kind of funny on my notes in front of me. I had Amarasate written, so I think half the podcast I was saying it wrong. But Amarasate seems to have a pretty impressive impact. And like you mentioned, because of the trilogy of the impact on CCK and PYY, two other hunger hormones, you're getting a little bit less of the deleterious effects of super amplified GLP-1 agonism. So I have kind of a personal question for you, Ed. Based on a lot of this research that you've done on antioxidants, on hunger suppression, et cetera, how does a guy like you eat?
So it's an interesting one. So I don't. Yeah. So people quite often ask me. They say, "Have I taken Amarasate?" And the answer is yes, I have. And they said, "Oh, were you overweight?" I'm like, "Well, I've never been overweight, but I'm just like anyone else, and I have cravings for food which are not great. And if I eat chocolate and cakes and chips, I don't put on fat, but my blood pressure goes up and my cholesterol goes bad. So I eat pretty well, to be honest. So I have berry smoothies in the morning with oat milk. I have every evening, so I eat the same food pretty much every night, which is black rice with a stir-fried veggie and lean chicken. My only vice is that I drink Coke, no sugar. So, I've got an addictive personality. I have to be addicted to something, and that's what I chose.
I don't know. I thought you were going to say beer, being from Auckland.
No, I'm not a drinker. Strangely enough, I'm not really that fond of bitter foods.
Yeah, well, I can get behind that. That's a decent approach. I mean, Diet Coke's better than regular Coke, I suppose. Yeah. So, as far as more research on Amarasate or other hunger-suppressing compounds, do you have anything else lined up?
Yeah, so right now we're just kicking off a weight loss trial with Amarasate. So that's 150 people looking at a 6-month weight loss to see how they go, evaluating not just changes in weight and body fat, but also body composition, because I think that's it's quite an important, with the Ozempic face and the muscle loss that's been associated with the use. I think that having a look at what Amarasate is doing in a clinical trial as far as muscle mass goes is quite important. We're probably going to extend out a little bit as well. So we may be looking at studies in postmenopausal women. So at need, so basically at risk groups. So say population groups who have a tendency to gain weight. How effective is Amarasate in that particular group? So I didn't mention, we've done 2 other clinical research studies on 24-hour fasting to look at changes in hunger and fullness, and also food cravings with Amarasate. And we can show that during the last 8 hours of the 24-hour fast, Amarasate is really highly effective at reducing increased hunger and increased food cravings, to the point where, in females anyway, they're craving food less at 24 hours into the fast when they've taken Amarasate than they were at 16 hours into the fast. So it's actually driving their cravings down. And so we want to take those results and we want to go forward and say, okay, if we implement a fasting type diet in someone who is overweight or diabetic, how good is Amarasate for them? Because they won't be able to fast to 24 hours. That's just too hard. They're probably going to be looking at fasting to 16 hours and getting the Amarasate a little bit earlier. So we're looking at that sort of research, getting the base research we've done and targeting it to the at-need populations.
Yeah, I hadn't even thought about this potential for the use of fasting. I haven't done any long-term fasting stints since I got on my hands on this bottle of Calocurb, but it would be interesting to see how it compares to other strategies that I've used for fasting, particularly ketones. So super interesting, man. Anything else you want to share about Amarasate or your research here?
Yeah, from a personal point of view, it's been immensely rewarding to do this kind of work. It's not, you don't get a lot as a scientist. You don't get a lot of chance to take something from really from the fundamental science all the way through to a product that's on the market. And I've been quite blessed to do that. I'm really hopeful that this development can help people make healthy food choices and to change their lifestyle for both not just weight loss but also improved health. And I'm always available if anyone wants to send a question in or ask about the product or the science and talk about it.
How do people get a hold of you if they wanted to do that?
Yeah, so it's just edward.walker at plantandfood.co.nz. So that's plant, then AND food.co.nz.
Got it. I'll put that in the show notes too. Hopefully by sharing that, you aren't going to get 120 spam emails signed up for sales and marketing advice. Put those spam filters on, bro. All right. Well, cool. Well, I'm going to link to all this stuff. If you're listening in, go to bengreenfieldlife.com/Calocurb, CALOCURB. I've got some discounts that Calocurb gave me on this product. I think it's Ben 10, as you probably would have guessed. But anyways, I'll put all of that in the show notes. You guys can leave your questions, your comments, your feedback there about GLP-1, about hunger management, about Calocurb, the active ingredient, Amarasate, or anything else that you want to know. The show notes are always nice and juicy. So bengreenfieldlife.com/Calocurb. Bonus points for anyone who beats me to throwing a Miracle Berry party and telling me what this stuff looks like post-Miracle Party or post-Miracle Berry dosing. Break it open, put it on your tongue. Let me know if it explodes or starts on fire or just tastes like the best candy ever. All right, until next time, I'm Ben Greenfield, signing out from bengreenfieldlife.com. Check it out, Calocurb. Have an incredible week.
Do you want free access to comprehensive show notes, my weekly roundup newsletter, cutting-edge research and articles, top recommendations from me for everything that you need to hack your life, and a whole lot more? Check out bengreenfieldlife.com. It's all there. bengreenfieldlife.com. See you over there. Most of you who listen don't subscribe, like, or rate this show. If you're one of those people who do, then huge thank you. But here's why it's important to subscribe, like, and or rate this show. If you do that, that means we get more eyeballs. We get higher rankings. And the bigger the Ben Greenfield Life show gets, the bigger and better the guests get, and the better the content I'm able to deliver to you. So hit subscribe, leave a ranking, leave a review if you got a little extra time. It means way more than you might think. Thank you so much.